In this lesson, I'm going to show you how to download and install SQL Developer. I have included a link to the SQL Developer downloads in the description below. So you just need to click on the download link. Once in the download page, you have to choose the installer that is appropriate for your operating system. I will select the download for Windows that doesn't include the JDK because I already have the JDK version 8 installed. If you don't have it, download the one that includes the JDK, so that you don't need to perform the two installations individually. Once you click on the download link, you will have to accept the license agreement. As usual, and then log into your Oracle account. If you don't have one, you can create an account for free by clicking on this button. Now, I tested this process on different browsers and for some reason, it many times failed on Edge. Sometimes the license dialog didn't show. Some other times the login dialog didn't show, and sometimes it worked. So, if it doesn't work for you, I would recommend using either Firefox or Chrome, and that will usually fix it. So, I will log in, and now I just have to wait for the download to finish. Okay, now we are ready to install SQL Developer. Actually, SQL Developer doesn't need to be installed. You just need to extract the zip file you downloaded, so go ahead and do it. I'm going to extract it into my download folder, but you can choose a different location if you want to. When the extraction finishes, I would recommend creating a shortcut to the application so that you can run it from the desktop. So, double-click on the folder that was created and create the shortcut. Now let's run it. If you downloaded the installer that doesn't include the JDK, then it will ask you for the location of the JDK first time as well. So if that happens, just browse to the root folder and select it, and you will be all set. When you run it for the first time, it will ask you if you want to import preferences from a previous installation. This includes connections, application preferences, etc. I usually say yes to this prompt, because when I install a new version I always want to use the preferences from the previous one. But in this case, I'm going to say no, so that I start with a fresh installation for the purposes of the course. I usually don't like applications to send usage statistics. So in this dialog, I'm going to clear this checkbox and click on OK. And that's it. With this, you have Oracle SQL Developer configured and ready to be used to access your database, which is great.
In this lesson we are going to take a look at the user interface. In general, it is composed of the main menu, which is here at the top of the window, a number of display panes, which are sections that display specific details like connections, reports, and some other things that are not visible by default, and the worksheet and code editors, which is where we write code and is usually what occupies most of the space of the window and will be displayed here in this area. So, taking a quick look at the main menu, we see that it has some options that are usually present in most development environments or editors, such as File and Edit. We are not going to pay much attention to them by now. This view option, however, is very important because there are a lot of features or things that are not visible by default, and this is where we can make them display. For example, if I close these panes and I want them back, I just have to go to the View menu, and click on the appropriate option to make them visible again. and the same is true for a lot of other panes that are available, some of which we will cover in another section. Then some other options like Navigate and Run are useful only when we are working with code on the worksheet or code editor. And the rest of the options are also not as important at this moment, so we will not look into them by now. Now, most of the sections or panes of the user interface are very flexible in terms of position and size. For example, if you double-click on the title, they get maximized, and if you double-click on them again, they get restored to their previous size. You can also move them around if you want to place them on a different position. And as you see, as I move them, this orange frame shows me the places where I can drop them, which are a lot. And I can create groups of panes. For example, if I drop this Reports pane here, it creates a group with the Connections pane, and now I can do some actions on the whole group, instead of the individual panes if I want to. For example, if I right-click here on the group header, I can close or minimize the group. And I can also float it, which puts the group on a separate window, which I can move even outside of the SQL Developer window if I want to. Then if I right-click on the Windows header, I can dock the individual panes or the whole group again. And I can also move one pane out of the group if I no longer want them to be together, so, this is really very flexible. And if you have a big monitor, or more than one, you might find this ability to display panes at different places and in different ways very useful. Now, if for some reason you make a mess of your panes, and want them back to where they were after installation, you can just go to the Window menu and select Reset Windows to Factory Settings, and everything is back to normal instantaneously. Okay, these are the basics of the user interface, but without a database connection there is not really much you can do. So, let's go to the next lesson, where you will learn how to create and organize your database connections. I'll see you there. Welcome back to the Oracle SQL Developer tutorial. Today we are going to learning how to create a database connection. For this tutorial, you need a database to which you can connect. SQL Developer does not include a database. You can use an Express Edition database, which is free to use, but it is a separate download and a separate installation, so if you still don't have one, please stop now and get your database installed. Okay, to create a new connection, you can right-click on Oracle Connections, here in the Connections pane, and select New Connection, or you can just click on this green plus icon here. This will open this dialog where you will have to enter the necessary details to create the connection. Here you have to give the connection a name, which I'm going to call SYS, but you can name it however you like here. There is a useful feature that many people don't use which allows you to define a color for the connection. By default, no color is defined, so all connections look the same, but when you define a color, the worksheet and the editors display with a frame or border of this color, and that makes it very easy for you to know or visually differentiate what database you are working with, and prevents you from making mistakes such as modifying or deleting data from a production database, thinking you were doing it on a test database, for example. So, my recommendation is that you always define a connection color. In this case, since I'm going to create a connection using the SYS user, which is a very powerful one, I'm going to assign a red color, to serve as a warning for me in the future. As I mentioned before, for this connection I'm going to use the SYS user, so, I'll go ahead and type SYS, and enter the password. Here, since I'm using the SYS user, I will change the role to SYSDBA, but if I were a normal user, I would leave it as default. And I have the option to save the password, so that it doesn't ask for it every time I open the connection. For the connection type, you can most of the time use the default, which is basic, so that is how we are going to do it. And here is where we define what database we want to connect to. In hostname, you can use the name or the IP address of the machine where the database is running. In this case, since I have the database running on my local machine, I will leave the localhost as the hostname. And the port used by the Oracle listener is by default 1521, so, most of the time you will use this default value as well. Now here, we have the option to use a SID or a service name. If you are using a multi-tenant enabled database, like the 18C Express edition, if you connect using the SID, you will be connecting to the root container, which might not be what you want, so, if you want to connect to a pluggable database or PDB, you have to use a service name. An explanation about the multi-tenant architecture and containers is out of the scope of this course. So, to connect to a PDB we have to enter the appropriate service name. In the case of the Express edition, the PDB that is created by default during the installation is called XEPDB1. Now we can go ahead and click on the Test button. If everything is correct, the test will succeed, and we can now save the connection. If you receive this I/O error saying the network adapter could not establish the connection, it is most likely because either you don't have a database or you are using incorrect data to identify the host or the database itself. So, if that is the case, please make sure that you do have a database installed and that you are using correct data to create the connection. Okay, once you have a saved working connection, the next time you want to connect to the database you just have to double-click on the connection, which will by default open the worksheet. SQL Developer allows you to organize your connections into folders, which is very useful when the number of connections starts to grow. To create a new folder you have to right-click on one of the connections you want to put in there and select Add to Folder. You will have the option to add it to an existing folder or create a new one by clicking on this small button here. In version 19.4 and in very old versions of SQL Developer, folders appear first in the list, but in other versions, they were ordered alphabetically together with individual connections, so, if you, like me, want them to appear first, just update to the latest version, where this bug is already fixed, but if that is not possible, you have to play with the folder names, and what I used to do is to prefix them all with a capital A. They don't get rearranged automatically, so I have to do something like toggling the connection grouping on and off, for it to show the new ordering. Okay. Now that you know how to create connections, you can start learning the basics of working with the worksheet. I'll see you in the next lesson. Welcome to the Oracle SQL Developer tutorial. Now we are going to take a look at the basic features of the worksheet. For starters, the worksheet will be open by default when you connect to the database by double-clicking on a connection, but if that doesn't happen, or if it does happen but you want to open another worksheet for the connection, you can right-click on the desired connection and select Open SQL Worksheet. The connection used for this worksheet will appear selected here at the top right corner and you can change the connection if you want to. So, you don't really need to close the worksheet and open a new one just to switch to another connection. Once you are here, you can start writing code, and keep in mind that every SQL statement must end with a semicolon. So, for example, if I want to get the date from the database, this is the statement I need, right? It ends with a semicolon. Now, to run it, I have a couple of ways. I can click on this green play icon here or I can press the Ctrl and Enter keys simultaneously. I prefer to do things with the keyboard, so I use the second option. In both cases, the command that will be executed will be the one where the writing cursor is positioned. If you want to run more than one command, or maybe only part of a command, you can select or mark the text you want to execute and then run it by any of the methods I mentioned previously. So, for example, if I have this query that includes a subquery, I can execute only the subquery if I want to. I just have to select only that part of the statement, and then run it. Of course, this wouldn't work if this was a correlated subquery. It would produce an error because the database would not recognize the references to anything that is outside of the part 1 I'm running. If you are new to SQL and don't know what a correlated subquery is, don't worry. What is really important for you to know is that you can execute only part of a command, if that is what you want to do. The specifics of this example are not really important. As you already noticed, the results of your queries are displayed down here in the result grid, which we will talk about in the next lesson. Okay, there is another way to run commands, which is to run them as scripts. We usually call a script to a sequence of more than one statement, but even if you have only one, you can decide to run it as a script by clicking on this icon here in the toolbar, or by pressing the F5 key. In both cases, it will by default execute all of the code you have in the worksheet, and the results will be displayed not in a grid, but here in the script output pane. And you can also select only part of the contents of the worksheet and run it as a script if you want to. Okay. The next 3 buttons of the toolbar are related to tuning features, so we will not talk about them right now but in another lesson. Then we have buttons to commit and rollback to finish your transactions, which you can also do by pressing the F11 and F12 keys respectively or by writing and running the commit and rollback statements manually, which is what I usually do. And we are not going to look at the rest of these buttons by now, as they are not really part of the basics of working with the worksheet. Another thing that is important here is that, as you might know, Oracle error messages many times tell you the line and position where the error was detected. But since the worksheet by default doesn't show line numbers, it is not really easy to find the problem, so, for a quick fix, you can just right-click here on the left margin of the editor, which is called the line gutter, and select Toggle Line Numbers. And if you want to go to a specific line number, you can press Ctrl+G, and it will take you to the desired line, even if line numbers are not being displayed. And the last thing I want to mention here is that you can format your code simply by pressing Ctrl+F7, which by default will format all of the code you have in the editor. But if you don't want to format everything, you can select only the part you do want to format and then press Ctrl+F7. This will apply a basic format based on a set of predefined rules, but you can customize the formatter. We will do that in a future lesson. So, don't forget to subscribe the channel to stay connected. Please comment below if you have any questions. Today we are going to take a quick look at the result grid of Oracle SQL Developer. The first thing to notice is that by default, SQL Developer will reuse the result grid. So, every time you run a new query, the results from the previous one will be lost. This might be convenient in many cases, but sometimes that is not what you want. So, there are several ways you can prevent that from happening. First, you can click on this push pin icon here, which will pin the current results, so that when you run a new query, a new result grid will be created and you will not lose the previous one. Another thing you can do is to right-click on the title of the tab and rename it. This will not only automatically pin these results, but will have the added benefit that you know what's there, because you gave it a meaningful name, as opposed to having tabs named Query Result 1, 2, etc. This is usually what I do, but there is a small downside. When I pin the results manually, I can hover the mouse over the tab title and it will show me a tooltip with the query that was run to get these results, whereas when I rename the tab, it will only show me the name of the tab. I can always click on the SQL button here on the Results toolbar to see the query, but that is a little less efficient. And the other thing you can do if you always want to get your results in new tabs is to go to the Tools menu and then Preferences, Database, Worksheet, and select this checkbox that read Show Query Results in New Tabs, and then OK. This will make it open a new Results tab every time you run a query, even if you run the same query several times. I don't like this option, and never use it, but I know people who does, so try it out and see if you like it. Another important thing to mention is that by default, SQL Developer will only fetch the first 50 rows of the results of the query. If you scroll down in the results and try to go below the 50th row, then it will fetch another 50 rows, and so on. So if you want to fetch all of the rows, you have to go to the end of the results, which you can do with the scroll bar, or by pressing Ctrl+End. This value can be increased to up to 200 rows, so, if you want to change it, you can go to the Tools menu, then References, Database Advanced, and you set the new value here in the Array Fetch Size, and then click OK. The next time you run a query, it will fetch up to the number of rows you just set. What else can you do with the results grid? Well, you can drag and drop columns to change their position in the results. And you can double-click on the column title to sort the results based on the value of that column. When you do that, it will show this blue arrow here, to signal that the column is being used for ordering. When you double-click on it the first time, it will order in ascending order. If you double-click on it again, it will order in descending order, and if you do it again it will not apply an ordering. You can even apply more complex ordering rules if you right-click on a column title and select the Sort option. Here you can add more columns to the ordering criteria, make it ascending or descending, leaving nulls at the end or at the beginning, etc. And you can also use this dialog to delete previous ordering rules. You can also filter the results, by clicking on this filter or funnel icon on the column title. For example, if I want to see only the employees from the department with ID 20, I can click on the department_id columns filter icon and enter 20 here, and press Enter, and it will apply the filter. If I want to remove that filter, I just click on the filter again and double-click on the Remove option that appears down here. Just keep in mind that these filter and sort operations are not done locally. What SQL Developer does is that it creates and runs a modified version of our query in which it adds an additional order by or where clause to give us the results we ask for, so if your query takes a long time to produce results, using these filtering and sorting features will actually take time as well, as the query will have to be executed again, with some modifications. And that's it. Now you know how to use the result grid. Today I am going to talk about Oracle SQL Developer Predefined Reports. OK. The Reports pane is visible by default, usually below the Connections pane, but if you closed it or it is not visible for any reason, just go to the View menu and click on Reports. Here we have a lot of predefined reports. In the last folder we will have the user-defined reports, which are the ones we will learn to build in the next lesson, depending on your specific job. You may find that many of these predefined reports will not be useful to you, but I will show you some of the data dictionary reports because some of them are quite interesting, and also because we need to look at some reports to explain the basics. For example, let's open the Data Dictionary Reports folder in here the All Objects folder, and let's take a look at the Invalid Objects report. As you see, when I click on it, it asks me for the connection that must be used, even though I have a connection already open. So, reports are connection independent and you can have a worksheet open with some connection and run your reports using another connection. Okay, I will select this one. And here is another interesting thing, you can parameterize your reports by means of bind values. This means that you don't need to define the report to check for fixed values in the conditions. You can use bind variables to let the user, or yourself, provide the value they want to use, so that they can run the report using different values, and thus, get different results according to their needs. In this case, for example, the report has a condition for the owner of the objects. If I enter some text here, it will restrict the reports to objects in which the owner is the value I entered. And in this case, if I leave it as null, the report is designed to include objects from all users, or in other words, it doesn't take the owner condition into account. Okay, I will leave it with null. Let's quickly take a look at this toolbar. This push pin is there because by default, every time you run a report, it will be displayed in the same Results tab. So, if you want to run a different report but don't want to lose the previous one, you have to pin it. Next, the play button causes the report to run again, usually because you want to refresh the results. Then, this icon, which I'm not sure what it is but says SQL, allows you to copy the report's query to a worksheet. This can be very useful if you want to understand from where or how the report is getting its data. In this case, for example, I can confirm, by looking at the query, that if I leave the owner as null, the report will basically ignore this condition, because it will always be true. We can also see that the way in which bind variables are defined in a report is exactly the same as we would define them in SQL Plus or the SQL Developer Worksheet. And finally, there is an automatic refresh option, which allows you to define how frequently you want the report to refresh its results. These values are seconds, so, if I select 5 here, the report will refresh automatically every 5 seconds, until I close it or I set this value back to 0. Now, let's quickly look at another report. Let's run this object distribution. As you can see, the data here is presented in a very different way. It even displays some values as tooltips when I hover the mouse over this 3D bars, which is kind of cool. And there are a lot of other reports. For example, if you're a DBA, or maybe even if you have your own database just for learning purposes, this Database Administrator folder has many reports you will probably find very interesting and useful. Another interesting example is the reports in the Table Quality Assurance folder. Here we have a report that shows a list of tables without primary keys, for example. We could get all of this information from the data dictionary views, but it would require us to know which views to query, and how. And we would have to keep our scripts safe somewhere to avoid having to write the same query every time, but a report makes it so much easier. So, take some time to explore the predefined reports at least once. You might find something you like. And when you are ready, let's move to the next lesson, where we will start talking about the user-defined report. In this lesson, we are going to start creating our own reports. There are several ways to create a user-defined report. The first one is by right-clicking on the folder where we want to create the report and selecting New Report. Another way to create a report is by copying an existing one, which can even be a predefined report, and then pasting it in the desired folder. For example, I will open the Data Dictionary Reports folder and then About Your Database, and I'm going to right-click on this Version Banner report, and here I will select Copy. Then I'm going to go to my User-Defined Reports folder, and I'm going to paste it here. Now this is a user-defined report which I can now modify if I want to. This is sometimes necessary because the predefined reports cannot be modified. Another way to create a report is by right-clicking on the results of a query and then selecting Save Grid as Report. This will open the report creation dialog so that we can add all the necessary details to the report that will be created based on the query we previously ran. And another way to create a report is to right-click on the folder and select the Open Report option. This will open a file browser I can use to open an XML file containing a previously exported report, which we will cover in another lesson. Here we are going to create our reports manually, and by doing so, you will learn what you need to know to be able to modify reports that you copied from the predefined ones, created from the results of a query or imported. So, let's right-click on the User-Defined Reports folder, and select New Report, and let's give it a name. I'm going to call it My First Report. Since this is our very first report, it is going to be very simple, so we are going to use table as the style, which is the type of report that is displayed in a grid, just like the results of a query. We can add some description, which is optional but recommended. And we can add a tooltip, which will be displayed when we hover the mouse over the report, in the Reports pane. And here we have to write the query that will retrieve the data for the report. Most of the time you will develop your query in the worksheet first and then will paste it here, but for this example, I will type here a very simple query from my EMP table. And these are the basic details I need. I can now click on Apply. And here is my new report. If I click on it, it will ask me for the connection I want to use, as usual, and it will run and give me my beautiful results. And with this grid, I can filter, sort, and many other things, just like we saw in the results grid lesson. Whose employees I want to include.
So that it asks me for the department ID whose employees I want to include.
What should I do? Come on, what should I do? Exactly, I just have to add a condition to my query, which uses a bind variable to ask for the department. Let's do it. It works. But if I leave the value as null, it doesn't return anything. What should I do to make it include all departments? When I pass null, I just need to modify the condition of my query. So this condition can become where the bind variable department as null or the depno column is equal to the bind variable. So, if I pass 10, it returns only the employees of that department. But if I pass null,
it includes all employees from all departments.
Pretty easy, right? And these results can be exported in different formats by right-clicking on them, just like the results of a query, but we will talk about exporting data in a future lesson, so I will not get into that by now.
In this lesson, I am going to show you how to create master detail or parent-child reports. I'm going to show you an example of a master detail report, so that you have an idea of how exactly they look like and how they work, and then we will build one. So, here in the data dictionary reports, database administration, there's weights and events. This is a master detail report. As you can see, it has two results grids, one up here and the other one down here. This is the master report, and this is the detail, and when I click on a row in the master, it retrieves the details for the master row I selected. So, if I click on the disk file operations IO, here I get all of the detail rows that correspond to that master row, so, if I click on another master row, the details will change accordingly. So, how do we build this type of report? It is not difficult. I'm going to show you. I'm going to create a report of departments which, when I click on a department row, will display the employees that work in that department. I will start by creating a new report in the usual way, just like we did in the previous lesson. I'm going to call it my first master detail, and I'm going to leave table as the style. And this time I'm not going to provide a description, just a tooltip. And here, I'm going to write the query for my master report. In this case, it's going to be a query from my dep table. And now I'm going to select this advanced checkbox, because it is necessary to be able to add a child report. As you see, now my query is in a separate section called SQL Query, and I have a new section for child reports, so I'm going to click on it, and here, I'm going to click on this Add Child button. I have to give the child a name, and I'm going to call it Carlos Jr., not funny, I know. I'm going to call it my first child. Now here in the tree, the child reports section has a plus sign, which means that I can expand it, and here is my first time. Here I am going to add a description and a tooltip. And now I'm going to click on the plus sign of the child, and I'm going to go to the SQL Query section. Here I have the query of the master report, and here is where I have to provide the query for the detail, or child report. So, I want the child report to be a report of the employees who work in the department selected in the master report, right? So, I need a query from the emp table. And now, before showing you how we create the relationship between the parent and the child, I want to show you something. If I select a connection here, this button gets enabled, and it allows me to test my report without having to leave the report editor. So, if I click on it, it runs the report with the data from that connection, which is pretty useful. So, here's my report, but let's see what happens if I click on a department here. As you see, it looks like the details are refreshed, but I get always all of the employees, not only the ones for the department selected, and that is because we have still not created the relationship between the queries. So, let's do that. The mechanism by which I can relate one query to the other one is based on the use of bind variables. The columns from the master query are available to the child query as bind variables automatically, so I just have to add a condition in my child query to make it return only employees from the selected department. So, I'm going to add a where clause here, and now I'm going to test it. As you see, there is no detail now, but if I click on a department, now I do get the employees of that department. Now, how exactly do I know how to write the condition in the child query? Well, the key is that all of the columns that the main query returns are available to the child query as bind variables, as I said before. So, if I want to add a condition in the child query, which involves a comparison against a value from the master or parent query, I have to use a variable that is called exactly like the column from the main query that it represents. And it has to be written in uppercase. And this is important, because if you use an incorrect name for the bind variable, or you write it correctly but in lowercase, it will not work. Okay. Now you know how to build master detail reports, but what about drill down reports? The concept of drill down is that you have a way to request more details about something, usually by double-clicking, using context menus or other similar methods. And the way in which we implemented in SQL Developer Reports is very similar to what we did with master detail reports. The difference is that to provide drill-down capabilities, we don't create a child report inside the definition of the main one, but instead, we create individual reports, which then we relate to their parent by means of bind variables. I'm going to create a new report of departments and a new one of employees, and we will add the employees report as a drill down, so that the result will be somehow similar to the master detail report we previously built, but the way to access the employee's information will be a little different. I'm going to create the department's report very quickly. And now I'm going to create the employee's report. In a similar way to what I did in the child report, I will add a where condition that compares the DEPNO column to a bind variable called DEPTNO in uppercase. Now, since this is an independent report, if I run it, it will ask me for a value for the bind variable, which is perfectly normal. But now, I'm going to add it as a drill down in the department's report, so edit. Now here in the drill down section, I click on Add Report. And here I provide a name. And I double-click here to select the report I want to add. Unfortunately, as far as I can tell, there is no easy way to find reports here, so I will just scroll down until I find the report I want. OK. Here it is. So, I can now apply. And if I run my department's report now, and I right-click on a row here, I have employees as an option in the context menu, and if I select it, it shows me the report of the employees of that department. And now if I click on this back button here, I now have departments as an option, so I can go back to the first report. And now, before your task, I just want to mention that you can have a main report with more than one child, and also with more than one drill down report, and you're about to test it by yourself.
In this lesson, things get even more interesting, because you will learn how to create reports that catch the attention of the viewer a little more easily than just pure text. Let's start by looking at gauge reports. I really like gauges, and as you will learn in a future lesson, you can display them in the results of your queries in the grid and they look beautiful and are very useful. But when it comes to gauges and reports, I don't think they're as useful, because in a report you can have more data in addition to the gauge itself. For example, I cannot have a report that includes the name of the employee, and a gauge for its salary. A gauge report can only include data from one column, which is what the gauge is going to be based on. For this reason, in reports, I only use gauges as child reports, and I think they are great for that purpose. So, I'm going to edit my previous department's report, and I'm going to add a new child report, which is going to be a gauge. I'm going to call it salaries, because my intention is to use the gauge to display the sum of salaries of all of the employees of the selected department. OK. Here I have to select the gauge style. And now, here in the query, I have to retrieve the sum of salaries of the department, so, select sum of SAL. From employer, now I have to add a condition that creates the relation to the main report. You remember how to do that, right? Where DEPNO is equal to DEPTNO, as a bind variable. Okay, let's test what we have so far. Check this out. That dial looks beautiful, don't you think? And when I click on the departments, the value of the dial changes, telling me the sum of the salaries of that department. But, what are these numbers and colors? What do they mean? Well, there are 4 additional numbers you can define for a gauge, which make it provide more context to the value of the gauge itself. In this case, 0 and 100 are the minimum and maximum values, and 33 and 66 are thresholds, so that the viewer knows easily that any value in the red zone is considered low, and any value in the green zone is considered high. These are the default limits and thresholds, but you can provide or configure your own values, which makes sense for the specific data you are displaying. One of the ways to provide those values is here, in the property section. So, I'm going to leave 0 as the minimum, but I'm going to set 11,000 as the maximum, because I know that is enough for all of the departments in this case. But what to use here really depends on the data you are going to include. And for the low threshold I will set 3,000, which means that, for me, a department with total salaries below 3,000 is considered too low. And for the high threshold I will use 10,000. Let's run it again. This is better. Right? Now, these 4 values are fixed in the report definition in this case, but I can also tell the report that they will be provided by the query, which allows them to change dynamically depending on the data. I just have to select this option. And then I have to modify the query to include the values, and this is very important. The query must provide the values in the following order. In the first column it must return the value for the gauge itself, which in this case is the sum of salaries. In the second and third positions, it must return the minimum and maximum values, in that order. And in the fourth and fifth columns it must return the low and high thresholds, in that order as well. You don't need to provide specific aliases, and the names of the columns can be anything, but they must be provided in the correct order. So, I'm going to add them here. In this case, just for the sake of this example, I'm going to provide them as constant values, but you could use any aggregate or analytic function to derive the limits and thresholds from the data. Okay. You might have noticed that here in the property section, there's gauge type that you can select. We are using the dial type, but there is also a status meter type, which looks like this. Again, the limits are at both ends of the bar, and the thresholds are marked with colors. And the actual value of the gauge is the black bar in the center. Pretty awesome, huh? But in this case, I prefer the dial, so I'm going to change it back. Okay, I'm done with this report, so I'm going to apply. And there is my new report, which I think you will agree is a little more interesting.
In this lesson, you are going to learn how to create chart reports, which in terms of visual appeal, are better than just pure text, but there are still limited regarding the type of data they can represent and regarding the way they present it. Fortunately, there is another type of report that really excel when it comes to presenting data in a visual way, and they are the chart reports, which are the topic of this lesson. I'm going to build a report of employees per department that will look like this. This was made with Excel, and our goal for this lesson is to learn how to create a similar chart report in SQL Developer. In this class I am only going to show you how to create bar charts, but SQL Developer offers many other types of charts. Some of them might be appropriate for one situation, and some other for another one, but the way in which they work and how you create them is basically the same. So, after you complete this lesson, I encourage you to try some other chart types, to get an idea of the options you will have available for your reporting needs. Okay, there are 3 concepts we need to understand to be able to work with charts in SQL Developer. They are the group, the series, and the value. In this graph, the groups are the department names that we see here, so they are what appear here along the horizontal axis. In the data from which this graph was created, they are here in this column. In Excel, and in other applications, these are called the categories, but in SQL Developer they are known as the groups. The series are what tells us what we are representing in the graph. In this case, we have only one, and it is the employees count. So, because we have only one series, we have only one bar per group. So, for example, if we wanted to graph the number of employees and the budget for each department, we would have two series, and thus, 2 bars for each group. And the value is the actual data we are representing, which defines the size of the bar. In this example, the shipping department has 45 employees, so the bar is 45 units tall. So, looking at the source data of the chart, you can think of the series as the title of the data, and the value as the actual data. Makes sense? Great. So, now that we have the basis covered and we know what we want to build, let's go to SQL Developer to create the report. I'm going to create a new report, and I'm going to call it my first chart, and here in the style I'm going to select Chart. OK. Now, for the query, this is how SQL Developer needs the data by default. The first column must be the group, so, in this case, it has to be the department name. Since I need the department name and I will need the count of employees of the department, I need to join the employees and departments tables, so this has to be the department name. The second column must be the series. And what is the series in this chart? The number of employees, or the employees count, right? But remember that it is not the actual number, but like the description of the number, so I will write the series as a literal and it will be employees count. And the third column must be the actual value, so that will be the number of employees in this case. So, how do I get it? Yes, of course, I get it using the count function. So, OK. This comes from employees join departments. On department ID. And I have to group by department name, because I want the count per department. OK, I will select a connection, so that I can preview my report. And there it is. That was easy. Right? OK. Here in the Properties section, there are several things I can customize. Here I can choose from a big number of chart types. This is a vertical cluster, and this is how it would look like if I had 5 series. If I change it to a vertical stack, all of the series show in the same bar, as segments of different colors. This is just an example, but if I go to the Data section, and I select this Use Live Data checkbox, I can see how it will look like with my actual data. Since I have only one series, a stack looks the same as a cluster, but with more series they would look different. So, going back to the main Properties section, besides the chart type, I can change the style and some other options. Here I can add titles and footnote, and decide how I want them to look. And here in the plot area and the 2-axis, I can make some additional customizations. I'm not going to do anything else, but I encourage you to try different things and see what they do. So, I'm going to click on Apply to save the report. If I now run it, here's my beautiful report, which looks very similar to the one we created in Excel, so mission accomplished. Now, adapting the query to comply with the columns that are required to build the graph was easy in this case. But what happens if I want to add another series, to show not only the number of employees, but also the number of distinct positions or jobs in the department? Let's review the column requirements. The first column must be the group. The second column must be the series. And the third column must be the values. So, I have only one column for the series, and only one column for the values. This means that my query would have to return 2 rows for each department, one in which the series is the count of employees, with its corresponding data in the values column, and one in which the series is the count of distinct positions. How can I do that? Well, I could use a union of 2 queries. The first one would be the one we already have, and the second one would be very similar, but with a different series column, and instead of a count star, it would have to have a count of the distinct job IDs. Or I could get both counts in a single query and then unpivot the results to separate the 2 counts into different rows. But, fortunately, we are not forced to comply with the default column requirements. We can get the data in some other format or column distribution, and then we can tell SQL Developer where it has to take the data from. So, forgetting about the column requirements, I can modify my query to return the 2 counts and series in different columns, and that would be easier. So, I will have another literal for the distinct positions. And here I will add another call to count, but now of the distinct job IDs. And that's it. I'm going to select a connection here. And I'm going to go to Property, Data, and I'm going to select this to use live data. And now here in the mapping I click this button to fetch the column names. And there is usually going to be an empty row here in the mappings, but if it is not there I would click this plus button to add one. Here I am going to select the group, which is the department name. The series will be the number of employees, and the value will be the count star. And now I add another mapping for the second series. Here the group will be the department name again. The series will be the distinct positions. And the value will be the count distinct job ID. And now I just refresh the report and there it is. Let's save it. So, using the column mappings it is easier to add more series. Okay, I just want to repeat what I said at the beginning of this lesson. We used a bar chart for this example, but SQL Developer offers many other options that could make more sense in other situations. For example, if you wanted to build a graph to show how much of the total budget of a company is assigned to each department, then a pie chart would make a lot of sense. But if you wanted to show sales numbers over time, then a pie wouldn't probably be the best option. A bar or a line chart would probably make more sense in that case. So, after you finish this lesson, take some time to explore and try some other graph types, so that, when the need to display information in a different graphical way appears, you have an idea of the options that are available in SQL Developer. And in case you were wondering, yes, charts can also have child reports. The child will be refreshed when you click on a group in the chart. That's pretty awesome, if you ask me. In this lesson, we are going to show you how to export and share reports. And even though I really like this feature, I have to be very clear about the fact that this is not an enterprise reporting solution. It has some very nice features, and we are going to look at some additional ones in this lesson. But if your company has more advanced needs, SQL Developer will probably not be enough. So, please keep that in mind. Okay. The first thing we are going to look at here is how you can share your reports definition, so that other users that have SQL Developer installed and have access to the database can run them on their machines as well. You have probably noticed that when you right-click on a report name here in the reports tree, you get a contextual menu, which among other things, offers a Save As option. This option exports the report definition into an XML file, which you can send to your coworkers for them to import it into their SQL Developer instance. To import the report, they just have to right-click on the folder into which they want to import it, and select the Open Report option. Since the report definition is independent of the database connection, they don't even need to have a connection with the same name as yours, because SQL Developer will ask them to select a connection when they run the report. Another interesting thing is that if you right-click on a folder and use the Save As option, the resulting XML file will include all of the reports that the folder includes in a single export file. Okay. You just saw how to share your reports with other people that have SQL Developer installed and have access to the database. But if you usually generate reports with static information, such as Excel files or similar, for other people that doesn't have access to the database, you will probably find what I'm about to show you very interesting. One of the other options we have in the context menu, when we right-click on a report, is HTML. And what it does is that it exports the report to an HTML page that you can send to someone else, or put in some network location for others to see. The export creates a folder in which it puts some images, CSS and JavaScript files, and this folder, along with the HTML file itself, contains all of the information included in the report, so anyone can just double-click on the HTML file and see the report's data from anywhere, without needing access to the database. I'm going to show you with my department's report. Here I just have to select the connection I want to use and the path where I want the report to be exported, and that's it. Look at the resulting page. And look at the gauge. It looks as beautiful as it did in SQL Developer. And if I click on the rows in the master report, the gauge actually changes. So, this is a fully functional master detail report. Let's look at another one. Look at this one. Even the mouse pointer changes as I hover over the bars, signaling that I can click on them. Again, I have a beautiful and fully working interactive report that I can send to other people, or put on a network folder for them to see. I just have to remember to share the HTML file and the corresponding folder for it to work. So, do you like it or not? Okay, this is not enough. Let me show you something else. SQL Developer has a command line interface, which allows you to do some things without opening the graphic user interface. And one of the things it allows you to do is generating reports in HTML format. Just to clarify things, because this can cause confusion, you may have heard of SQLCL, a standalone application that is also a command line tool to work with a database, which supports SQL plus commands and allows you to run queries and all that stuff. That is not the command line interface I'm talking about. I'm talking about another command line interface that is more limited in functionality, and is actually an interface that allows you to tell SQL Developer to do certain things without using the graphic interface. Jeff Smith, the SQL Developer Product Manager, has mentioned that they have plans to unify these two command line interfaces into a single tool, but I don't really know when that will happen. Okay, the command line interface executable we will use here is in the bin folder of the SQL Developer installation, so if I didn't add the SQL Developer path to the operating system's path variable, I have to navigate to its folder, or at least include its full path when invoking the program. So, the syntax for generating HTML reports using the command line interface is this. After the command line interface executable, I have to write reports generate report, and then the name of the report, which in this case is departments. Then I have to add DB and the name of the database connection, which in this case is course, XCPDB1, and then file and the name and path of the destination HTML file, which I'm going to call just departments HTML, without a path, so that it gets created in the same directory. And that's it. If I did everything right, my report is now ready. Let's see if that is true. Yes, here it is. Now, why is this so useful? It might be useful because I could automate the generation of my reports. If I use the Windows Task Scheduler to execute this command daily, for example, or I can put the command in a cron job if I'm on Linux, so my reports could be generated regularly to a predefined location, without any intervention from me, even when I'm not in the office. I think this is very convenient and can be a huge time saver if your job includes generating reports for other people. One small caveat is that this would only work automatically if the password of the connection is saved. Otherwise, it will ask for it and will not run until it is entered. Okay. There is one final trick I want to share with you about reports. I'll see you in the next lesson.
In this lesson, I'm going to show you a couple of ways to make the most of the space on your monitor or monitors when using SQL Developer. Many years ago, when monitors were usually smaller and had smaller resolutions, having only one window or document visible at a time was the norm, but that's no longer the case for most people. With the big monitors we tend to use these days, there's plenty of space available, and we usually want to take advantage of that by having more than one window or document visible simultaneously. When it comes to working with SQL Developer, most people tend to use more than one worksheet to do their jobs. Many times people have more than one worksheet open. In addition to that, they have one or more PL/SQL editors, and maybe some other type of documents, such as the information of a table or something similar. But as you might have noticed, by default, you will only have one of all of those documents visible. If you want to view another one, you have to click on it to select it, which will make it become visible over the previous one. But it doesn't have to be that way. SQL Developer allows you to have document groups. And this is awesome because one document from each group is visible at a time. And this is something that is very easy to do and can have a great impact on your productivity. For example, if I want to see this worksheet and this PL/SQL editor at the same time, I just have to separate one of them into a different document group. And I do that by right-clicking on the Document tab and selecting New Document tab group. And now I can continue working on this editor while also having this worksheet with its results visible, or vice versa. And I can move this document from one group to the other one if I want to. And I always have one document from each group visible. And I can do this as many times as I want, or my monitor space allows me to. And besides moving documents from one group to another one, I can move them to different positions and organize them as I prefer. And I can even right-click on these documents and click on Float to detach them from the SQL Developer window, which can be very useful if you have more than one monitor, because these detached documents can be moved freely. You cannot see that I moved this one to my second monitor because I'm only recording this one, but this way I can have even more documents open concurrently. This flexibility really helps me be more productive because I can see all that I need to see just by moving my eyes, without needing to be clicking here and there to do it. Do you think it will be useful to you? Alright, I'm going to show you another feature that is somehow similar to this one, but first I'm going to undo this tab group separation. To do that, I just have to right-click on the tab title and select Collapse Document tab group. Okay, I don't know if this happens to you, but I remember that somewhere in the past, I used to find myself scrolling up and down on my worksheet to see or even copy some command I had run previously, Many times I had to copy it just because I wanted to run it again, but I didn't want to have to be scrolling up every time I needed to execute it. So I just copied it and pasted it at the bottom of the worksheet, near the code I was currently running or writing. But then I found out that this was an unnecessary waste of time, because there's a feature in SQL Developer that could help me with that. I just had to split the worksheet. For example, I have this worksheet that includes a lot of statements. If I'm writing code here at the end, but I will need to be running one of the commands I have at the top of the worksheet, I don't need to copy the command here to have it at hand. I can just right-click on the title of the worksheet and select either split vertically or horizontally. And now I have the same worksheet duplicated here. So now I can run the statement from the top of the worksheet from here and continue writing code here at the end. As you see, I have the results of this query here. And if I run another query from this side of the worksheet, I have its own results here, so I can see both simultaneously. But this is actually the same editor. I'm going to scroll down here to show you. If I write something here, the changes are reflected on both sides, which is kind of cool. And I can continue splitting it as many times as I need. If I want to get back to a single worksheet, I just have to right-click here and select On Split. And this can be done with other types of documents as well. For example, I have the information of this table here. I can split it and then select a different tab on each side, which allows me to see different details of the same table simultaneously. And when looking at a table and also in the PL/SQL editor, there is an even easier way to split the documents. Do you see these little blue bars that appear at the top and bottom right corners? I can simply click and drag to split the view. If I do it with the one on the top, it will split horizontally. And if I do it here, it will split vertically. Do you see how flexible this thing is? I really like these features and I use them a lot. You should try them right now. I will see you in the next lesson.